Hello everyone and welcome to IB Math SL. We're going to start right away into one of the most basic and fundamental things in math, which are basically the number systems. So we'll start off with the first one. The first one is called the natural number system, or natural numbers. So it sort of looks like this italicized N, and I'm just going to write natural numbers, right? And what it is just it's a set of numbers, okay? And I'm going to start it from 1, 2, 3, ... all the way basically to infinity. Now, according to mathematicians, there's actually no formal definition of natural numbers. So some mathematicians like to start the natural numbers with 0. Others like to start with 1. For our purposes in IB Math SL, we're going to call natural numbers starting with 1. And the reason why they're called natural numbers is because in nature, we count things in discrete units, 1, 2, 3, 4. You don't really see 2.5 rabbits or 3 1/4 of a horse. You just count them in nature. So 1, 2, 3, 4, all the way to infinity. The next very important set of numbers is the set of integers, and it sort of looks like a Z, but remember, again, it's an italicized Z, and it is the set of integers. What are integers? They're basically the set of, they basically go from negative infinity, and again, just very discrete units, no decimals or anything like that. So -2, -1, 0, 1, 2, 3, and all the way to positive infinity. So that's natural numbers and that's integers. One thing I just want to bring to your attention is that the natural numbers, which you can see 1, 2, 3 for infinity, all the way to infinity, basically is a sort of a component of the integers. So you can see that the integers are really comprised of the natural numbers plus all these other set of numbers, so 0, -1, -2, -3, all the way to negative infinity. So it's really, really sort of important to remember that the natural numbers sort of fit neatly inside the integers. The next things are, what I'm going to sort of highlight is, I'm not going to line this up here, just a little bit indented. So let me just use yellow here just to be consistent. Or actually I'll use blue because I want to indent it. So this is basically the set of integers, but if I put a little plus there, what it means, it's positive integers. So these are the set of positive integers. And what it is again just the set of positive integers. So we're really just looking at a subset of this set of integers. So in other words, it's just 1, 2, 3, all the way into infinity. We're ignoring the negative because clearly that positive sign just means we're only focused on the positive ones. And similarly, if I just put a little minus there, that's a set of negative integers. So negative integers. And again, so this is going all the way from negative infinity, so 3, -2, -1, and there we go. And we don't include 0. Neither of them include 0 because 0 is sort of an ambiguous symbol, has an ambiguous sign. It's neither positive nor negative. So therefore, it's not included in either the positive set of positive integers or the set of negative integers. All right. So the next number system that's really, really important that we need to understand is the set of rational numbers. So it's written by the letter Q. Again, it's in sort of an italicized Q, and it's called rational numbers. And what it is it doesn't really mean that these numbers are more sane than some other set of numbers, though some would argue that. What it is, focus on this word ratio. All right. So the word rational numbers, what they are is basically any number. So I'm just going to write any number that can be expressed as a fraction of 2 integers. All right. So let's go through a couple of examples sort of to identify what's a rational number and what's an irrational number. So let's do an example. So for example, the number 2/3, this is a rational number because, first of all, it's a fraction. The numerator is a 2, which is an integer. The denominator is a 3, which is also an integer. So therefore, this is a rational number. Let's take the number 5. Now, 5 obviously doesn't look like a fraction, but you can think of it as 5 over 1, because that's what it is. And again, this is expressed as a ratio of two integers, so therefore this too is also a rational number. Let's take a number like, say, 3.14. Now, even though this is a close approximation to pi, it isn't pi, all right? So what this is, it's simply 3.14. And this too can be expressed as a fraction of two integers. So it's going to be, for example, if I write 314 divided by 100, this is a ratio of two integers, because 314 and 100, they're both integers, and therefore this is also a rational number. And again, if I have -7 over 4, remember, rational numbers is not exclusive to positive numbers. They can also be negative. So therefore, if you look at this negative, again, an integer in the numerator and an integer in the denominator, so therefore this too is rational. Let's sort of look at a number that is not rational. If we look at, say, pi is actually 3.14159, and sort of it goes on forever. And it actually has been proven that there's no way to express pi as a ratio of two integers. So therefore, pi itself is irrational. It's not a rational number. So it's really, really important to remember that this is not a rational number. Once again, I just want to highlight one thing. So now I'm just going to move on to the next set, which is, again, if I just say rational, this q plus, it means the set of positive rational numbers. So this is a set of positive rational. I'm just going to put this sign, positive rational numbers. And obviously, if I do this, similarly, if I put a little minus there, it just means negative. I'm just going to write NEG, negative rational numbers. And I hope you understand that just means negative. All right. Now, the next very important set is something. So we describe Q as the set of rational numbers. What about the irrational numbers? How would we write them? So the way we write them is we write a Q, and we express it in one of two ways. We can either put a little prime, okay, or what we can do is we put a little Q and we put a little C, and this C means complement. And it's not like a compliment like, a little thank you or anything like that. That's not what it means. It just means anything other than a rational number. So this Q stands for obviously rational, and Q complement means anything that is not rational. So the exact opposite. So the way we describe this is the set of irrational numbers, meaning that this is just a set of numbers that cannot be expressed as a fraction of two integers. So this is irrational numbers, right? So let's go over a couple of examples of irrational numbers. So let's do pi, as we said. So pi is irrational. Like I said, it cannot be expressed as a fraction of two integers. So this is an irrational number. Later on, we're going to study this natural number e, which is 2.718. It comes in nature, and don't worry, I'll explain how we get E and how it comes about later on in the course. But for now, you should know that if you ever see the letter E, which stands for 2.718 and so on and so forth, this again is an irrational number because it cannot be expressed as a fraction of two integers. So what about something like, say, pi over 3, right? You might think like, oh, well, this is rational. Well, no. Remember, what's the definition of a rational number? It's that it's a fraction where both the numerator and the denominator are integers. Well, 3 is an integer, but pi isn't. So this too, even though it's expressed as a fraction, because pi is not an integer, this too is an irrational number. Now, the last thing I want to go over is what is known as the real number system. So it's expressed as italicized R, and it's called the real numbers. The real numbers. And what it is just basically, it's a combination, all right? It's just a combination of the rational numbers and the irrational numbers. So in other words, Q complement. So it's just the combination of the two. So in other words, it's basically any number that you know of. So for example, the number 1, that's part of the real number system. 2/3, that's part of the real number system. So even though the real number, so 1, 2/3, let's say 3.14, Again, these three are all rational. Pi as well, right? So these are rational, and now let's include a set of irrational numbers. So pi, let's do negative e over 4. Remember, e was irrational. So this is, again, another irrational number. So the real number system is just basically these two combined, all right? And that's basically it. That's all the number systems that we're going to be dealing with. There is another number system called the opposite of real number systems, and they're called imaginary numbers, but we're not going to be dealing with them in this course. What I just want to highlight is how all of these number systems, some of them tend to be embedded in another. So when we looked at the very first one, let me just scroll all the way to the top. We noticed, for example, say the natural numbers were embedded inside the integers. The integers, if you have noticed, are actually embedded inside the rational numbers. They're embedded inside the rational numbers. Now, the rational numbers are not embedded inside the irrational numbers. So they're just coming up right now. The rational numbers are not, say, a part of. Remember, they're the complement. They're the exact opposite. They're the exact opposite. So the rational numbers and irrational numbers, like basically, they will never have any numbers in common. They're completely separate. So it's important to remember that the natural numbers are embedded inside the integers are embedded inside the rational numbers, and the irrational numbers are just completely different from anything that's inside the inside the rational numbers. And then the combination of both the rational and the irrational basically make up the real number system, which is this over here. All right, so I'll see you in the next video then.